Hello guys, this is Wait Lounge Learning Made Easy, and in today's video we are going to be considering a very important concept known as reactions of amines. Mind you, it's important that you like, share and subscribe to this channel. So let's get into it. The reactions of amines can actually be classified into three, and they are addition reaction, substitution reaction and oxidation reaction. If we are to consider the addition reaction that occurs in amines, there are basically two of them: reaction with acids, and then secondly, your reaction with aldehydes and ketones. The very first thing I would like to say is that if you have a substance that neutralizes an acid, it is most likely going to be a base. So what does that tell you? Amine is a base. So let's get into the addition reaction. Addition reaction is basically a reaction in which two reactants combine together to form just one product. And as we said, one of the most important addition reactions that occurs in amine is the reaction with acids. So which means that amines are considered as base. Why are they considered as base? Amines are Lewis base simply because they donate their lone pair of electron. Any substance that donates its lone pair of electron is referred to as a base, which means if it accepts a lone pair of electron, what you refer to it as is an acid. So let's get to it. Imagine I have a primary amine, for instance, and this primary amine possessing a lone pair of electron combines with an acid. Mind you, an acid in this case contains a proton which would want to accept a lone pair. So what automatically happens is this proton moves and then accepts this lone pair. As it does that, it forms an ammonium ion. However, this ammonium ion is what we refer to as alkyl ammonium. Why? It has an alkyl group attached to it. So which means you have this, and then your lone pair where you have hydrogen proton attached. If this occurs, the bromine ion would eventually be attached, and eventually this alkyl ammonium will combine with the bromine ion, and collectively this would become an alkyl ammonium bromide. So which means if this was chlorine, it will become an alkyl ammonium chloride, and so on and so forth. Now this particular reaction is supposed to happen for both primary, secondary and tertiary amines. So let's go to the second type of addition reaction that occurs in amines, and that is the reaction with aldehydes and ketones. For you to be able to understand this, let's clear the air about what aldehydes are. Aldehydes are organic compounds that possess terminally positioned carbonyl group. A carbonyl group is simply carbon having a double bond to oxygen. And when that particular carbonyl group is terminally placed in a particular chain of hydrocarbons, automatically this is referred to as an aldehyde. If the carbonyl group is placed on a non-terminal carbon atom or located on a non-terminal carbon atom, automatically you refer to this as a ketone. So this is a ketone, while this is an aldehyde. Now, reactions with aldehydes is dependent on what class of amine. For instance, the tertiary amines do not react in any way with aldehydes. Tertiary amines plus aldehydes, you would automatically have no reaction. So which means what we are going to be considering is the reaction of aldehydes and ketones with either secondary or primary amines. So let's see what happens. If you have a primary amine, R attached to nitrogen, hydrogen, remember that the primary amines are characterized by the presence of two hydrogen atoms attached to nitrogen and one alkyl group. If this particular primary amine, Da, tends to react with an aldehyde, let's say we have ethanol, the very first thing that happens is that there would be a formation of a carbinolamine group or carbinolamine compound. So let's get to form the carbinolamine. The first thing that happens in the formation of the carbinolamine is that hydrogen moves from this point and then goes towards oxygen, where it tends to break this double bond between oxygen and then attaches itself to it. So you have that the product is going to be more or less CH3 attached to C. Instead of having a double bond with oxygen, it now forms a single bond with oxygen, and the oxygen takes the bond it usually had there and then forms it with this hydrogen. Remember, this hydrogen has to leave. So the implication is that there is now space or one bond freely hanging on this carbon. That is actually where this nitrogen now gets attached to. So you find out that in this end, the nitrogen from this place will be attached to at this end. So you are going to have nitrogen to R to H. This particular compound, where you have a hydroxyl group attached to an amine, in this case, is what we refer to as a carbinolamine. So this is because you have a hydroxyl group attached to the same carbon to which an amine is attached to. This is what we refer to as a carbinolamine. Now, because this is a primary amine and it has hydrogen to lose, what automatically happens in this case is that this particular carbinolamine would become further dehydrated. So which means we need to remove water from it. And once you remove water from it, you have a product known as the amines. Now, an amine is simply a product that is formed where carbon forms a double bond with nitrogen. This is what we refer to as amines. It is completely different from your enamines. Your enamines are produced when you have nitrogen attached to a carbon, and probably in that chain there is a double bond present in that chain. So if the carbon is double bond attached to nitrogen, it is referred to as an amine. But when the double bond is existing between carbon atoms which eventually are attached to nitrogen, what you have this as is an enamine. So that's basically the difference. So as I said, now once you are dealing with a primary amine, as you can see in this case, we are dealing with a primary amine. If it tends to be dehydrated further, the OH would leave and this particular hydrogen would leave. This will lead to the formation of a new bond, and hence you are going to have, after dehydration or removal of water, in this case, you will now have CH3C. The OH is no longer here, which means you have two free bonds. And then nitrogen loses one hydrogen and then forms or attaches that remaining bond to this guy. So what you have is that you would have a product where there is a double bond formed between carbon and nitrogen. And when you have carbon forming a double bond between nitrogen, you will refer to this as an amine. So have this in mind, that this is what we refer to as an amine. Hence, you would have that the summary of this statement is that primary amines, when they react with alkanals or alkanones, would lead to production or formation of amines at the end of it all. So that's that basically about the reaction of a primary amine with an alkanal or an alkanone. If you are considering the reaction of a secondary amine, a secondary amine is characterized by attachment of two alkyl groups to nitrogen and one hydrogen. If it is to combine with an alkanone or alkanal, let's in this case use an alkanone, you are going to have, first of all, the carbinolamine will be formed initially, and then after that we'll see what would eventually be produced. So when this reaction occurs, as I said, this hydrogen that is here would actually attack the oxygen, therefore increasing the saturation of this compound because it's going to break this double bond. It basically converts this carbon to an sp3 hybridized carbon atom. So what you're going to have is CH3C, but instead of having a double bond attached to oxygen, it's now one to oxygen, and then the hydrogen becomes attached to the oxygen. So you now have CH3. Now remember, carbon can form four different bonds, so it has one free bond at this end. This is actually the bond that is now formed between this particular guy is severed, so nitrogen is now free to come and attach itself here. And if it does that, you're going to have nitrogen attached to R, attached to R. Notice something, I didn't necessarily change anything. This is an addition reaction. And what this product is referred to as is a carbinolamine. Remember, I said a carbinolamine is basically formed when an amine is directly attached to a carbon possessing a hydroxyl group. Now, when dealing with your carbinolamines formed from your secondary amines, automatically, if dehydration is to occur, you would have hydrogen removed from one of the carbon atoms and OH removed from this end. And if that happens, you are going to have CH2, a double bond formed carbon, and then you are going to have nitrogen attached to R, and the other nitrogen attached to R, and then you have CH3. That's basically what happens. So in the case of your secondary amines, after the carbinolamine is formed and dehydration occurs, your product formed is an enamine. So you have that secondary amines, when they react with alkanals or alkanones, would lead to the production eventually of an enamine. So when an amine group is attached to a particular alkene, alkene is the double bond, automatically you refer to this as an enamine. But in the case of primary, as I said, primary amines, when they react with your alkanals or alkanones, will lead to the production of imines. Tertiary amines, on the other end, do not react with alkanals or alkanones. So you have that basically. So these are the reactions or the addition reactions that are being described to regularly occur in amines. So we get to the next type of reaction that occurs in amines, and that is your substitution reaction. Now, in the substitution reaction, there are two major reactions that occurs with respect to substitution of your amines. The first one is the acylation reaction. The acylation reaction is basically a reaction between an acyl chloride and an amine. Now, the acyl chloride is a product of halogenation of your alkanoic acid or your esters, where you have, for instance, you have an alkanoic acid which tends to react with something like phosphorus 5 chloride, and when that reaction occurs, the OH group is basically replaced by one of the chlorine. So when that happens, you will now have that this is the product CH3COCl. This is what we refer to as an acyl chloride. So which means that an acyl group is basically formed when an alkyl group is attached to an alkyl, a carbonyl group which is attached to a halogen basically, and this is what we refer to as your acyl chloride. Now, when your acyl chloride tends to react with an amine, what basically happens is that the amine replaces this particular halogen basically, because this amine is more nucleophilic than the chlorine here, and because it is a beta nucleophile, it tends to replace this particular chlorine which is a less nucleophile, and this is what we refer to as our nucleophilic substitution. So just have that in mind. Now, when you are dealing with an acyl chloride, if an acyl chloride is to react with an amine, okay, let's say for instance we have a reaction between an acyl chloride and a primary amine. If it is to react with a primary amine, automatically what basically happens is that the amine loses this hydrogen while the acyl chloride loses this chlorine. The two of them eventually would combine to form the hydrogen chloride, while there would be a bond formed between this carbon and this particular nitrogen. So let's see what happens as the product. So the product will now be R attached to C, double bond O. Instead of having chlorine here, this nitrogen now forms a bond, and that's why we have a nitrogen. Remember that the nitrogen initially was attached to hydrogen and the alkyl group. Then on the other side, hydrogen combines with chlorine to form the hydrogen chloride gas. So you have this, that anytime an acyl chloride reacts with an amine, automatically you get an amide. So the implication is acyl chlorides or acyl groups plus a primary amine, in this case, led to the formation of a secondary amide and hydrogen chloride gas. So you have that in mind. Now when a primary amine reacts with an acyl chloride, it produces a secondary amide. Why is this an amide? An amide is basically formed when nitrogen is attached by a single bond to the carbonyl group. So when nitrogen is attached by a single bond to the carbonyl group, this is what we refer to as an amide. If it has an alkyl group attached to it, this is referred to as a secondary. But if you only have two hydrogen atoms, it's basically a primary amide. So have that in mind, that an amide is formed when a carbonyl group is basically attached to by a single bond to nitrogen. So just have that in mind. Now when an acyl group reacts with the primary amine, what is going to give as its product is a secondary amide. And I've explained how this reaction basically occurs. Okay, so let's go into some other reactions that could occur. Let's attempt performing a reaction between an acyl chloride and a secondary amine and see what happens here. So as stated initially, this particular chloride will combine with this hydrogen and the both of them will form a hydrogen chloride, while there would now be a bond formed between this particular carbon and this nitrogen. So the implication is that our product will now be R attached to C. Remember, just maintain everything that has been there, and then instead of having a bond with chlorine, it changes the bond to nitrogen. Remember, this nitrogen initially had two alkyl groups, so automatically it tells us that when you have an acyl chloride reacting with a secondary amine, it leads to the formation of a tertiary amide, and in this case hydrogen chloride gas. So basically these are the reactions that occur with respect to substitution in amines, and this type of reaction is what we refer to as an acylation reaction. The final reaction under substitution that we are going to be considering is the reaction of amines with nitrous acid. Now, this particular reaction would also serve as a test to differentiate primary amines from secondary amines and tertiary amines. This particular reaction is what we refer to as your Van Slyke's method of identifying the primary, secondary, and tertiary amines. So amines with nitrous acid is what we refer to as Van Slyke's method of differentiating the primary, the secondary from the tertiary. So let's get to work. If you have a primary amine and it tends to react with nitrous acid, what basically happens in that particular process is that, okay, so nitrous acid is diazonitrate 3 acid. Mind you, nitrous acid is not directly added to this particular solution. Nitrous acid is actually added in the form of sodium diazonitrate 3 and HCl. Because if you add the nitrous acid directly, the reaction becomes extremely vigorous. However, just note that when you combine these two things, what you are going to get is still the nitrous acid, which is HNO2. Now, during this particular reaction, what basically happens is that in the case of primary amines would first form your diazonium complexes or your diazonium salts. So if we are to form the diazonium salt, a diazonium salt is characterized by a triple bond between nitrogen atoms, which eventually is combined or attached to a carbon atom. This particular combination would give it a relatively positive charge, which means that it can combine with an anion. However, the diazonium salt or diazonium ion is a very unstable ion, which means that it will eventually break down to form other products. But let's go on. So as I said, when you react a nitrous acid with a primary amine, the first thing that is formed is your diazonium salt. So, or your diazonium ion. The diazonium ion, as I said, is when there's a triple bond between nitrogen, which is attached to an alkyl group or just a carbon atom generally. Once this happens, this is a diazonium salt. Now, this particular diazonium salt is unstable, and because diazonium is unstable, and because it is unstable, it will eventually split into an alkyl carbocation, which means you have the R group with positive sign in addition to nitrogen gas. So you have this. Now, whenever you react a nitrous acid with a primary amine, what gas is going to be given off? Nitrogen gas. This particular carbocation, dependent on the reactants. If you have a hydroxyl group present, the carbocation reacts with the hydroxyl group to form an alkanol. On the other hand, if you have a chloride group present, this carbocation in the presence of a chlorine group would react to form a chloroalkane, depending on what this particular alkyl group is. If, for instance, you don't have any of these and you decide to remove a molecule or an atom of hydrogen, automatically it will lead to the production of an alkene. So the point is this: the diazonium ion being unstable will break into a carbocation and nitrogen gas. This carbocation will now break down or react with other reagents to actually form the alkanol or the haloalkane, or better still, remove a hydrogen atom to become an alkene. And that is basically that about the primary alkanol. Which means when I want to identify if it is a primary alkanol, it is expected that when it reacts with nitrous acid, nitrogen gas will be given off. So the most important emphasis in this case is that nitrogen gas would be given off. So once you have a production of nitrogen gas, automatically you refer to this as a primary amine. Okay, so let's see what happens in the case of a secondary amine. Now, for your secondary amines, when the secondary amines react with the nitrous acid, you have a different product. As we know, the secondary amine is basically nitrogen attached to two alkyl groups and one hydrogen. When it reacts with your nitrous acid, basically what happens is that a molecule of water is removed from the mixture, and then you have a product known as the N-nitrosoamine. So HNO2. If this reaction is to occur, the alkyl group will be attached to nitrogen, which is still attached to the alkyl group. But however, this hydrogen is lost. And when hydrogen is removed, you have a free bond. This free bond is now attached to your nitroso. This nitroso is basically what attaches to this secondary amine to give it its characteristic yellow color. So you have that secondary amines, when they react with your nitrous acid, you are going to have a product known as the N-nitrosoamine. So basically, remember, a molecule of water was actually removed. So this particular compound has an oily yellow color. And basically, that's that. You identify the secondary amine by this oily yellow color. The primary amine, on the other hand, when it reacts, you would have nitrogen gas produced. Finally, we will have a reaction between the tertiary amines and your nitrous acid. This particular reaction will lead to the formation of your nitrosoammonium salt. Now, it is very important for you to note that this particular nitrosoammonium salt is colorless, which means you will not see any color change in the mixture as this process occurs. So which means using your Van Slyke's method of differentiating, primary amines would react with nitric or nitrous acid in this case to give nitrogen gas. Secondary amines would react with the nitrous acid to give an oily yellow mixture, while in the case of tertiary amines, when it reacts with your nitrous acid, you would have no visible reaction. Note, I did not say no reaction, but the reaction would not be visible. So that's that about your Van Slyke's method for differentiating that. And as I said, this is basically one of the reactions or one of the substitution reactions that occurs in your amines. Now, anytime you have an aryl amine and your aryl amine basically forms more stable diazonium salts. Initially we said that whenever your primary amines react, that your primary amines, if they are alkyl amines, what they are going to give are diazonium salts, which are unstable. However, the aryl amines, which are amines or primary amines that are formed from the benzene ring. If you consider the benzene ring, okay, let's look at that. If you have the benzene ring is basically the hexagonal structure with the circle. If it is a primary amine and it is a primary aryl amine, if it tends to react with the nitrous acid, the diazonium salt form is actually more stable than that of the alkyl. However, its stability occurs at 0 degrees Celsius. So, which means that it forms more stable diazonium salt. So, the diazonium salt of your arylamine at 0 degrees does not decompose. This particular diazonium salt of the arylamine is very useful in the dye industry as a solvent. That's that about the aryl amines and the diazonium salt formed from them. So let's move ahead to the final reactions that are supposed to occur in your amines. And that final reaction is the oxidation reaction. Now, generally speaking, amines can actually undergo direct burning in oxygen to produce carbon dioxide, water, and nitrogen, or its nitrogenous oxide. However, we are going to be considering one of the oxidation processes known as Milder's oxidation. Now, Milder's oxidation involves the use of sodium hypochlorite as an oxidizing agent to react with amines. The point about it is that if you happen to use Milder's oxidation where sodium hypochlorite is reacting with a primary amine, the product of that reaction is a nitrile. If, for instance, the reagent sodium hypochlorite is reacting with a secondary amine, the product of that reaction is an imine. And if, for instance, sodium hypochlorite is used to react with a tertiary amine, the product of that reaction is an imine. I've explained these things. A nitrile is basically formed when carbon has triple bond with nitrogen. So this is the nitrile. An imine is when carbon has double bond with nitrogen. And an enamine is when nitrogen is attached to a single bond to carbon atoms that possess a double bond between them. So you have this. Nitrile is produced by Milder's oxidation with primary amines. Your imine is produced with Milder's oxidation with secondary amines, and enamines are produced with Milder's oxidation in tertiary amines. This is very important to note. Having said this, the final form of oxidation that we are going to be considering is the oxidation using hydrogen peroxides. When you happen to react your primary amines, so in this case we are considering H2O2 plus primary amines. If you react your H2O2 and your primary amines, what is usually produced is your nitroso compounds. Your secondary amines, on the other hand, would lead to the production of your hydroxylamine. So just have that in mind. Now, when you react hydrogen peroxide with your primary amines, you have a production of your nitroso compounds. On the other hand, hydrogen peroxide reacting with secondary amines will lead to the formation of your hydroxyl amine. The hydroxyl amine is basically a combination of hydroxyl and amine group. So basically, you have that your hydroxyl amine is NH2OH, basically. And then finally, when your hydrogen peroxide reacts with your tertiary amines, it basically leads to the formation of your amine oxides. So basically, where you have more or less the this particular compound form. And that's generally about the reactions of amines. As I said, I hope this video has been helpful to you. This is Wits Lounge, learning read easy.